Thank you. I ask you to switch on my presentation. I don't know if it goes so. May I ask you? Or I try to make no, please, no problem. So, ladies and gentlemen, dear colleagues, dear friends, as you know, I am for the experiment, because in a museum it is serious if there are only dead objects. But the experiments, the living experiments, are more interesting than only the objects. And it is a very important role of a museum. Now, we celebrate, as we heard, we celebrate now the 4th birthday of our museum, perhaps I dare say our museum. And 4 years, it is not such a long period in the general history of natural sciences. But it is not a short period in the history of electrical engineering. In electrical engineering, the practical application of electricity is not so old. The practical application, we say in English, electrical engineering, or in Italian, elettrotenica, because it began just here in Pavia in 1799, when the professor of physics of the university, Sandor Volta, discovered the galvanic electricity and invented the first continuous source of electricity, voltaic pile, and more powerful cells, galvanic cells, and galvanic batteries. That is my from line. Oh, no, that's okay. And just the voltaic pile, Alessandro Volta demonstrated his famous voltaic pile to Napoleon, or here is the powerful galvanic battery. The voltage of the battery was very low. Because in the electrostatics, the voltage is 1000 volts, and the voltage of the galvanic cell is 1 or 2 volts only. But it could give a few amperes current, a million times higher than that of the electrostatic machines, and it enabled very important discoveries. The discovery of electrolysis, generating heat or even light by electricity, and first of all, the electromagnetism. Nevertheless, the electricity, or a special form of electricity, a brilliant phenomenon, the lightning, was known even in the prehistoric times. That is a cylindrical seal from Babylon about 2,200 years before Christ, and you see there the hand of the god of the weather, of a bundle of flames. That were the lightnings. And then in China, the god of the thunderbolt was illustrated by drums, and the drumstick in the hand, surrounded by tongues of flames. And in the Hellenic art school, the lightning was demonstrated as a fire in the hands of the gods, and even before Prometheus stole the fire from the gods, Zeus itself lit the first fire in the Earth. And the scientist says that lightning played an important role in the development of mankind because it acquainted the caveman with the fire. Now it is a fine drinking vessel from 480 before Christ. From the Greek science tried to give a theory of the lightning, and Aristotle said that it is a special art of fires. The clouds consist of earth vapor that contract in the cold surroundings and make a self-ignition. Now from the Greek physics remained 2000 years, nothing else up now but the name of this special chapter of physics, electricity and electrical engineering, Tecnica, and so on. The new age of the electricity began in the 17th century. Here it is the famous burgomaster of Magdeburg, Otto von Guericke, and he constructed the very first friction electric friction machine. It was nothing else but a rotating sulfur globe rubbed by the hands of the experimenter. And at the beginning of the 18th century, Francis Hosby made very interesting experiments because perhaps inspired by Newton, made measurements in vacuum, whether the forces in the open air and in vacuum are similar or not. And he saw in a total darkness a light in the evacuated bulb. That was the first electric fire. And it is interesting because up to the 17th century, there was no connection between fire and electricity, no connection between electricity and light. That was the first case that electricity could cause a very, very poor light. Nevertheless, in the darkness, it was a light. And they constructed different such friction machines, and the big friction machines could give also sparks, little lightnings, and after, in the middle of the 18th century, Dalibard made such experiment in Paris and proved that in the clouds there is electricity, and in the same year made Benjamin Franklin the famous kite experiments and proved that the lightning is an electrical phenomenon indeed, and could make the first practical application of the new knowledge. It was not just to use the electricity, but to avoid the buildings from unwanted electricity from the lightning. That was the lightning rod of Faraday. And the giant big experimental devices, it was the friction machine of Matthias von Marum, with a big glass disc. The diameter was about 1 meter and 65 centimeters, and it charged a big Leyden jar battery consisting of 100 Leyden jars, and it gave 600 meter long sparks, and it was very strong, and it looked like that indeed so as a lightning. And now, after the friction machines, back to Pavia, because it was a new system to generate electric charge electrophore by the electric induction, electrostatic induction or influence, we can say also influence. It was the electrophorus of Volta. That was a new system, and by this influence or electrostatic induction, later, 100 years later, there's an experiment with the electrophorus. And 100 years, about 90 years later, Wilhelm Holtz and Toppler in Germany constructed such an influence machine. It was not only, the charges was generated not by friction, but by the electric influence, by two glass discs rotating opposite. And now, and after it came the machines of Wilson. It was at the beginning of the 19th century, of course, from the United States, the giant of the electrostatic machines. The practical application of such machines was the X-ray technology, because it could give a voltage high enough for the X-ray technology. And at the end of the 19th century, it was the electrostatic machine of Wimshurst, of the English Wimshurst. And let me show you here a little Wimshurst machine in operation. After my lecture, we can go into the museum, and then we, I dare say we, together with Professor Savini and the group, decided to furnish here a corner of electrostatics. And the museum a few years ago has got a fantastic, fine old Wimshurst machine. And Mr. Girardin helped us to repair this old machine. It's not yet absolute ready. Nevertheless, we can show it, and perhaps in the next year it will be in its final form. Now I show you now this little. This is a little Wimshurst machine. I try to show it in operation, and it gives fine little sparks. It looks like a light. Nevertheless, I want to show you something else. Now I make here a high voltage transmission line of electricity, like in the fields, the high voltage transmission lines. This is one wire on the transmission line. Here is the other. Here the voltage is high enough, because if here is the spark gap about 5 centimeters, 1 centimeter, it means about 20 kilowatts. So it means that the voltage is 100 kilowatts, like the high voltage transmission lines. And now I show you something else. The mechanical effect of the electricity. It is a very primitive little electrostatic motor. I made it from a usual plastic bean cup, and it is very good for teaching physics in the schools, or even here demonstrated in a museum. Even the children made such experimental motors. Now I give electricity, and you can see